Function composition is another function operation, but it's different than addition, subtraction, multiplication, and division. It's an operation that we can't really do with numbers. We can't compose two numbers, but we can compose functions. If you think of compositions elsewhere, in music, a composition involves taking multiple parts, putting them together. So a function is a specific way to take multiple functions and compose them into one new function. Let's look real quick at function notation. So this is something that we've looked at this year and seen occasionally. If we have some function f of 2 is telling us to plug 2 into that function, right? Plug 2 in for x and see what value that spits out. So f of 2 is telling us to plug in 2. Composition, function composition, is when we basically plug an entire function into another function. So just like f of 2 is telling us to plug in 2, this would be read f of g of x, which is telling us to plug g of x into the function f. So rather than just taking a number and plugging it in, we'll be plugging in whatever function we have for g of x. So this is function composition. Don't get this confused with multiplication. Notice that the g of x is inside these parentheses. It's not f of x parentheses g of x. Okay? So this is function composition. And another way to write function composition is with this little circle here. It looks like it says fog, but that's not quite an O. It's this little circle, and we would just read this as f of g of x. Okay, so that's function composition. So let's look at a couple examples. In this first example, we're given f of x is equal to 2x plus 3, g of x is equal to x squared plus 1, and we're going to do the composition both directions. So we're going to compose f of g of x. So we take f of x, so this is equal to f of x, which is 2x, and something's going to go in for that x. Right? When we plug something into f, it goes for the x there. And what we're plugging in is g of x. So for the x right here, we plug in this whole thing, this x squared plus 1. So 2 times x squared plus 1 plus 3. And then we just work that out, simplifying it. So distribute the 2, and we have 2x squared plus 2 plus 3, which is going to give us 2x squared plus 5. So f of g of x is equal to 2x squared plus 5. Now going in the opposite order, g of f of x, this is not going to be the same thing. There's something special about the two functions if it does turn out to be the same thing when we do the composition either way. But g of f of x is going to usually be something different than f of g of x. So here we're doing g of f of x. So we're going to start out with g of x. So we have x squared, so something squared. We're going to plug something in for that, and what we're plugging in is f of x. So 2x plus 3 goes in for x. So we have 2x plus 3 squared plus 1, and we would go on to multiply that out. So if we FOIL, that will give us 4x squared plus, we would have 6x and 6x, so plus 12x, and then 3 squared is 9, plus 1. So we're going to end up with 4x squared plus 12x plus 10. Okay, so function composition, we plug one function in for the other function. One common mistake that people make is, let's go back to f of g of x. One common mistake that I see is, one, either just doing multiplication with the two functions, doing 2x plus 3 times x squared plus 1, but that's different. We already did that earlier. Multiplication is a different operation. The other mistake that I see is when plugging this in, still keeping the x that's in f of x. I see this common mistake where this x gets left in here. That shouldn't be there because the x squared plus 1 is going in where we have that x. Okay, so don't make either of those two mistakes. Don't just multiply, and make sure that you plug our other function in for the x into the one function that's being composed with it. One other type of example that you might see might have, instead of f of g of x, it might be asking you to find f of g of some value. And there's a couple different ways that you can go about doing these. You could do function composition and find f of g of x, which we've already done. We've already seen that that is 2x squared plus 5. So f of g of 2 would just be asking us to plug 2 into that equation. So we would plug in 2 right here, and 2 squared is 4, times 2 again is 8, plus 5 is 13, so f of g of 2 equals 13. But there's a couple other ways that you can do this. The first thing is to look at what is g of 2, and g of 2 we would plug into g, and so we would have 2 squared plus 1, which is 2 squared is 4, plus 1 is 5. Okay, so then since g of 2 is 5, then we have f of 5, and so we would plug 5 into f, and that would give us 2 times 5 plus 3, and 2 times 5 is 10, plus 3 is 13. So this comes out to 13. So you have a couple options. You can either find f of g of x as its own function and then just plug that value into that function, or you can do it a step at a time and do g of that value. Whatever you get out from there goes into f. You plug that in, and then whatever that spits out is your composed value. One last thing that I want to note, we won't go through this whole example, but we hadn't seen this in any of the previous ones yet, is what to do if our function has more than one x in there. And another common mistake that I've seen is when we compose something into a function that has more than one x, I've seen people just plug it into the first one and they ignore the second one. So here if we have f of x equals x squared plus 2x minus 6, and we're composing that with x plus 1, we have to plug g of x in for both of those x's. Okay, so if we have 2 places where we see an x in our original function, there's going to be 2 places where we have to plug in that x plus 1. So we're going to have x plus 1 squared plus 2 times x plus 1 minus that 6. Okay, so don't leave one of those x's out. Just like if we were to evaluate f of 2, we would have to do 2 squared plus 2 times 2 minus 6. That 2 gets plugged into both places. It's the same for function composition. That x plus 1, or whatever function it might be, has to go into both spots.